Hi everyone, this is Eric. Today we look at a problem called subarray sum closest. Given an integer array, find a subarray with sum closest to 0, return the indexes of the first number and last number. So when we come across problems involving subarray sum, the sum of subarray elements, here's a common technique we usually use and we will be using today. Let's say if we have an array, we want to get the sum of a subarray of all the elements in the subarray. Let's say this is index A, this is index B. So a common technique will be, instead of adding all the elements in the subarray, first we calculate the sum of all elements in front of index A, and then we calculate the sum of all the elements in front and include index B. And the subsum of A and B is sum B minus sum A minus 1. So here I don't have time to prove it, but we can assume it works. And let's say I'll give you an example. Here we have an array of 1, 2, 3. Its index is 0, 1, 2. Then we calculate the sums. Is 1. First number subarray sum is 1, and 1 plus 2 is 3. 1 plus 2 plus 3 is 6. So now let's say if we want to calculate subsum 1, 2, which is just two elements, 2 and 3. So according to the equation, we need to get sum 2 minus sum 0. So here we have indexes sum 2, which is 6, and minus sum 0 is 1. So which is 6 minus 1 is 5. That's exactly 2 plus 3. Yep. So the result is correct. But here we have a problem. Let's say, what if we want to get the subsum of 0, 1? According to the equation, we have to calculate sum 1 minus sum 0 minus 1 is minus 1. Apparently, this index is illegal. So what we will do is, there's a technique. So before we do any calculation, after we get the sum of the subarrays, we always set the first element, add the first element to be 0. So now the indexes of the sum becomes 0, 1, 2, 3. So the corresponding index in the original array is 1 less than the corresponding sums in the sums array. So this equation has changed to something like this. For example, if we want to get subsum of A and B, and the B becomes B plus 1, A minus 1 plus 1 is basically A. So the equation has changed to sum B plus 1 minus sum A. So now, if we want to calculate subsum 0, 1, we can do it, which is sum 1 plus 1 is 2 minus sum 0, which is, let's say, sum 2 is 3, sum 0 is 0, which is 3 minus 0 is 3. That's exactly 1 plus 2. So the result is correct. Let's write some code. So first, we want to have a look at the parameters, if it's legal or not, if it's none, or its length is 0. Apparently we don't have to apparently we don't have to calculate anything because there's nothing in the array, so we can just throw an exception, legal argument, or whatever, and then we can create a sums array. As we've discussed, the sums array will have one more element than the original array is the first element, which is 0. So when we are creating the array, it will be the length plus 1. And now let's generate the sums. As we remembered, instead of start from 0, we start from 1, because the first element is by default 0. And it's pretty simple. Sum I, it's sums I minus 1, numbers I minus 1. And how to get to the closest subarray after we generated the sums array. Let's say we generated a bunch of sums array. So let's say the y-axis is a value. We generated a bunch of array. The value can be negative as well. How do we know which subarray has the closest sum to 0? And actually, we can sort this array. So if we remember the original index of each sum, let's say this is, and so the subarray sum is the distance between the neighboring sums. So this distance is the subarray between those two sums, and this distance. So we just need to find the smallest differences in the neighboring sums. And another thing we need to do, we need to remember the original indexes. Let's say this one, 0, 1, 2, 3, 4. And now this becomes 2, 0, 1, 4, 2, 3. Let's say if this part is the smallest difference we can find, then the subarray between 2 and 4 has the closest subsum to 0. So in order to do that, we need to create a data structure. Originally, I was thinking about using a map, but then these numbers can overlap. You can have multiple sums with the same value. Let's say, in this case, a map will lose all the information of the sums. So we have to create a data structure to do that. Let's create a class. Private static class. We call it entry. So let's create a constructor where we have a value which is the sum, and the other value is the indexed. Okay, that's about it. It's very simple data structure. So in order to get the results, we need to create a data structure. Basically, it's the same basically which is the same, let's say, which is the same as this sums array. So every time, remember the first element needs to be 0. So we need to manually create a new entry to reflect the first element. Then each element is the same as sums. Sorry, we need a new. Now we have an array of the sums and indexes. So what we need to do is to sort this array. As we've seen before, now we need to sort the array. So let's sort. So here we need to pass a comparator. Okay, which is O1 sum minus O2 sum. So after this step, the entries array is sorted. We just need to find the minimum differences between the entries. So notice that okay, that's first let's define my integer called max diff. Let's get the max value of an integer. And notice here okay, then let's go through the entries array again. Again, instead of start from 0, we start from 1. So if xdiff is bigger than the differences, let's calculate the differences. It's I sum minus entries I minus 1 sum. If the max diff is bigger than diff, then max assign the diff value to the max, and we need to create a result, of course. Which is a two-dimensional, an integer array with 2 elements. So let's just store the values into the result, and we already get the sums. Now we just need to get the indexes. The sequence doesn't really matter. We will sort the result later. So after going through this loop, we pretty much get the the closest subarray. And all we need to do now is actually calculate the result and return the result. So as we've seen from this equation, and so here the b plus 1 is the index we have saved now, and is one of the index, the bigger index. This is another index. So all we want to do is to figure out which index is the smaller one. The smaller one is A. The bigger one is b plus 1. Then the bigger one is to minus 1. So what we will do is pretty simple. We will just sort. Again, we will just sort this array because it's natural order, so we don't have to pass in a parameter. Then the bigger one with minus 1. Then we can return the result. So here there's another thing to do. Okay, it looks like we have finished, but there's one more thing where notice here we are comparing the integer max value with the diff value. But the thing is, inside of the array, it actually can contain elements that's with the max value. Then this comparison doesn't work. So instead of creating greater, we actually need to change to greater or equal to. Okay, that's about it. Thanks for watching. See you next time. Bye.